This honors geometry lesson on section 4.1 will cover the properties of parallelograms. The objective is to know and utilize the definition and properties of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Looking at the diagram, remember that arrows mean that the lines are parallel and not necessarily congruent. The following theorem states some properties common to all parallelograms. Theorem 4.1 states that opposite sides of a parallelogram are congruent. So if we are given parallelogram EFGH, we are going to prove that the opposite sides of segment EF and segment HG, and that segment FG and segment EH are congruent. So if we draw a diagonal, e.g., we can use what we know about proving triangles congruent and what we know about using CPCTC to prove that the opposite sides in a parallelogram are congruent. So what we know, based on the given information, is that if this figure is a parallelogram, we know that opposite sides are parallel. So we can go ahead and mark that HG is parallel to EF and that HE is parallel to GF. So if we use EG as the transversal for sides HG and EF and sides HE and GF, we know that we have alternate interior angles are congruent. So we can mark our alternate interior angles. We can also mark that EG is going to be congruent to itself based on that reflexive property. And if you look at the two triangles contained in parallelogram EFGH, we can prove those two triangles congruent based on angle side angle. And once we know the triangles are congruent, we can then use CPCTC to prove that the opposite sides of the parallelogram are congruent. So we can now mark that HG is congruent to EF and that EH is congruent to GF. Based on Theorem 4-1, we have the following corollary. If two lines are parallel, then all points on one line are equidistant from the other line. In the given diagram, we are given that line L is parallel to line M. A and B are any points on line L. We are also given that segment AC is perpendicular to line M, and that segment BD is also perpendicular to line M. So we can now use the information that we know about parallel lines to prove that the distance from A to C is the same as the distance from B to D. Since points A and B are contained on line L and points C and D are contained on line M, and we know that line L is parallel to line M, we know that segment AB is going to also be parallel to segment CD. Because AC is perpendicular to M and BD is perpendicular to M, we now know that A and C is parallel to B and D. So now we have opposite sides are parallel, so we can say that ABDC is a parallelogram, and based on Theorem 4-1, we now know that opposite sides are congruent. So we know that AB is congruent to CD, and that AC is congruent to BD. So now we have proven that the distance from A to C is the same as the distance from B to D. Theorem 4-2 states that opposite angles of a parallelogram are congruent. So we are given parallelogram EFGH, and we are going to prove that angle H is congruent to angle F, and angle E is congruent to angle G. So again, I'm going to draw my diagonal, EG. And based on the markings that we did for Theorem 4-1, we can now mark that EG is congruent to itself based on reflexive property. And based on what we know about alternate interior angles, we can mark that this angle and this angle are congruent because they are alternate interior angles, and also that this angle is congruent to this angle based on the same reason, which is alternate interior angles. So again, we can prove these triangles are congruent using angle side angle. And once we know that the triangles are congruent, we can then use, again, CPCTC to prove that all the sides and all the angles are congruent. So now I know that angle H is congruent to angle F, and those are your two opposite angles. I also know that the entire angle of E is going to be congruent to the entire angle of G. So there we have proven that the opposite angles of a parallelogram are congruent. The last theorem that we're going to look at today is theorem 4-3. The diagonals of a parallelogram bisect each other. We are given parallelogram QRST with diagonals QS and TR. And we need to prove that QS and TR bisect each other, which will allow us to say that the diagonals of a parallelogram bisect each other based on what we know about proving triangles congruent. So what we're going to do first is we're going to go ahead and look at some of the other properties that we know about parallelogram. And the first thing we know is that in a parallelogram, opposite sides are parallel. So we're going to mark that QR is parallel to TS and that QT is parallel to RS. And again, with parallel lines cut by transversals, we have alternate interior angles are congruent. So if we use the transversal of QS, we can say that angle 1 is going to be congruent to angle 2. And if we use RT as our transversal, we can say that angle 3 is congruent to angle 4, which is down here. Let me erase that. Okay. And then if we go back to theorem 4-1, we've already proven that opposite sides of a parallelogram are congruent. So now we can mark that QS is congruent to ST. I'm sorry, I should say QR is congruent to ST. So as you can tell, we can now say that these two triangles here are going to be congruent based on angle, side, angle, which is going to allow me to use CP/CTC to prove that QM is congruent to SM and that TM is congruent to RM. So if QM is congruent to SM and TM is congruent to RM, we can say that QS and TR bisect each other based on the definition of a segment bisector. This is the end of today's lesson. If you have any questions, feel free to watch the video for a second time. After watching the video for a second time, if you still have questions, write down any clarification questions you may have and bring them to the next class.